Think about the last time you bought something on Amazon. You find your item, you click place order, and that's it. It feels like magic, right? Well, behind that single click, there's this incredible, complex dance happening between two very different sides of the web. In this explainer, we're going to pull back the curtain and show you exactly how all of that magic works.
So, here's our game plan. We're going to start with what you actually see, the visual part of a website. Then we'll journey behind the scenes to the heavy machinery that makes everything tick. We'll figure out how these two sides actually talk to each other. And finally, we'll discover where all this stuff lives out there in the cloud.
Okay, first things first. Every single website you've ever visited is split into two fundamental parts, what we call the front end and the back end. If you can wrap your head around this one idea, you're well on your way to understanding all of web development. It's that important. The easiest way to think about it is like a retail store. The front end, that's the storefront. It's everything you, the customer, sees and interacts with. The displays, the products on the shelves, the checkout counter. The back end, on the other hand, is the warehouse and the office all rolled into one. It's where the inventory is managed, where records are kept, and where all the real business logic happens. One is for presentation, the other is for power. So let's start in that storefront, the front end. This is the world you experience directly. And it's built using a trio of core technologies that work together to create literally every single web page you visit. These are the three pillars of the web. First up, you've got HTML. Think of this as the bare-bones skeleton of the page. It provides the structure and the content. Then, CSS comes in and adds all the style. It's the clothes, the paint, the design that makes everything look good. And finally, you have JavaScript. JavaScript is the brains of the operation. It adds interactivity, so when you click a button, something actually happens.
Of course, building a massive site like Facebook with just those three basic tools would be, well, pretty tough. That's why modern developers have a whole ecosystem of power tools. You've got frameworks like React that make managing all that interactivity way easier. You've got bundlers to organize the code, and other tools like TypeScript and Sass that are like supercharged versions of JavaScript and CSS.
And that brings us to the million-dollar question. You're on this beautiful, interactive page, the front end, and you click that big place order button. But how does that signal get from the pretty storefront to the powerful back-end warehouse to actually process your order? How do they speak to each other?
Welcome to the engine room. This is the back end. When you click that button, a message shoots out from your computer, travels across the internet, and arrives at a powerful computer that's been specifically programmed to listen for it.
This whole setup is called the client-server model. It's actually a pretty simple idea. Your web browser, that's the client. It makes requests. Amazon's powerful computer on the other end, that's the server, and its entire job is to listen for those requests and know exactly what to do when they arrive. So how do you actually build a server? Well, you start with a programming language to write the basic instructions. But to make life easier, developers use a framework, which is like a toolkit of pre-built parts. And to use code written by other people, they use something called a package manager. You can see there are lots of options, and the choice really depends on what you're building. But wait, where does the server save your order information? It can't just keep it in its short-term memory. For that, it needs a database. The database is the application's long-term memory. It's a totally separate, specialized piece of software that's designed to do one thing really, really well. Store and retrieve huge amounts of data, like all your past orders or every product on the site. Okay, so we know the front end sends a message and the back end gets it. But what does that message actually look like? Are they speaking English? Code? What's the common language here? Well, this is where the API comes in.
This whole conversation follows a really simple pattern. We call it the request-response cycle. The front end sends a request with all your order details. The back end gets it, does its work, saves the order in the database, checks inventory, and then it sends a response back, probably a confirmation message. This simple back and forth, it's the heartbeat of the entire internet.
Now, this might look like scary code, but it's actually pretty readable. This is a simplified version of a request. The first word, post, tells the server what to do. In this case, create something new. The next part, Amazon.com/orders, tells it where to do it. And the stuff in the brackets is the data, the items you bought. See? Not so bad.
Now here's the crucial part. A back-end server won't just accept any random message you send it. It has a very specific list of requests that it's programmed to understand. That list is its API, the Application Programming Interface. The best analogy is a restaurant menu. The API tells the front end exactly what it's allowed to order from the back end. You can't ask for a steak if it's not on the menu. And to keep those menus from being a chaotic mess, developers often follow a very popular set of design principles called REST. With a RESTful API, the different types of requests have standard meanings.
Post is always for creating something new, get is for retrieving information, and delete, well, that one's pretty obvious. This standard makes APIs predictable and much easier for developers to work with.
Okay, so we have servers running our backend code and databases storing our data. But where are these computers physically? Are they in a server rack in an office somewhere? Well, not so much anymore. These days, pretty much everything lives in the cloud.
So instead of buying their own expensive physical server hardware, companies now just rent computing power from massive cloud providers like Amazon Web Services or AWS, Google, and Microsoft. And this is an absolute game changer. It means a company can instantly scale up to handle the holiday rush and then scale right back down in January, only paying for exactly what they use.
Now, these cloud services come in a few different flavors. At the most basic level, you have Infrastructure as a Service, or IaaS. This is like renting an empty plot of land. You get the raw virtual computer, but you have to manage everything. The next level up is Platform as a Service, or PaaS. This is more like renting a furnished apartment. You just bring your code, and the cloud provider handles the rest. And finally, you have SaaS, Software as a Service. That's like staying in a hotel. You're just using a finished product, like Gmail or an email sending service.
You can imagine, for a huge company like Amazon, that back-end code can become one giant tangled block of code, what developers call a monolith. It's a nightmare to update. So, the modern approach is to break it up into microservices. You have one small, independent service that just handles orders. Another one just handles payments. Another one just sends emails. This keeps everything separate, focused, and way easier to manage.
So if we boil it all down, what are the absolute key takeaways for someone just starting out? It really comes down to these three things. You need to understand cloud computing, which is how you rent a server. You need a backend framework to actually build your server's logic, and you need a database to store all your data. Those are the three fundamental building blocks for pretty much any web application today.
And there you have it. From the visuals you interact with every day to the global network of cloud computers that power them, you now have the complete blueprint for how the modern web works. The only question left is, what are you going to build with it?